Hi there, Pre-Calc students. Welcome to our first online lesson from Chapter 2. This one's 2-1 Systems of Equations in Two Variables. You're familiar with systems of equations. You've seen them in some other math classes, I'm sure. It really means just more than one equation to be solved at a time. So we're really looking for where they have shared solutions. And as you can see down here, we have several methods of solving systems, which we're going to look at here. Graphing, substitution, elimination. You've seen those before. Perhaps the new one you haven't seen much of before is by matrices, so we'll see that today, and we'll also work on that in class. And here's Brandon scratching his head here a little bit, but we're confident that he'll be able to solve these pretty accurately in a little bit. Alright, here we go. Get right to it here to solve by graphing. And so graphing means that we're going to graph each one of these equations, each one of these linear equations, and see if we can find the intersection. So my first one here I'll do in red. A disadvantage here is that sometimes I can't graph it very accurately. But my first one, I see that the y-intercept, this is in slope-intercept form, my y-intercept appears to be 6, so I'll put a dot there. And my slope is -1, so that means I just go down 1 and over 1 like so. And so that's what that's going to look like. I'll try to draw that graph in there the best I can. A little bit inaccurate there, but that's okay. Now my next one is in standard form. I'm going to try, I think this one will be a decent one where I'm going to solve this using that intercept method or try to graph this. So I see that if x is 0, then y would have to be -6 in order for that to work. And if y was 0, then x would have to be 2. So I have the point 0, -6, which is down here, and 2, 0, which is here. And if I graph those 2 points, looks like that. And my solution, even though it's not real great because I didn't do it super accurately, I think is going to be the point 3, 3. Again, when you do this on paper, you'll be able to do a little bit better job at it. But this is just one of the drawbacks of solving systems by graphing, in that unless you graph it really accurately, you might be prone to some mistakes. So that's solving a system by graphing. We have another way that you're probably familiar with, and this is with substitution. Substitution means that I'm going to substitute one of the values in place of the other equation and then solve from there. Usually it works best when you solve by substitution if you have a single variable. Notice in this case it's kind of tailor-made because we have one of the equations is already solved for y, and that works out pretty nice. So what I'm going to do here is I'm going to take this 3x minus 8, which is what y is equal to. I'm going to plop that in place of this y, and I'm just going to rewrite it. So then I have 2x plus, but instead of y, I'm going to write 3x minus 8. And then that's going to equal 22. The advantage here, as you can see, is now I have an equation that's in one variable. I should be able to solve for that variable and go from there. So 2x and 3x is 5x minus 8 equals 22. I'm going to add 8 to each side, so 5x equals 30. So then x equals 6. And then I can take that and substitute that in another equation here. Go back to my top one actually. And as long as x equals 6, then I know that y equals 3 times 6 minus 8. So that's 18 minus 8, which is 10. So my overall solution then for this system will be the ordered pair 6, 10. This is an algebraic way of solving a system of equations, and you've done this before. Many students find this way to be a little tricky, and it can be because of the heavy dose of algebra involved in each of those substitutions. The most popular method, called elimination, which you might remember. With elimination, we're actually going to add up various columns here. We're going to try to eliminate one of the variables. So, similar to substitution, we can have one equation in one variable that we can solve for. So, what I'm looking for is opposites. I'd like either my x's or my y's to be opposites when I add them up. You see that in this case that's not the case yet. So you can manipulate one of these equations to create an opposite situation. Perhaps you see that maybe the best route to take here would be with my y's, because if I were to get this term as a negative 6y, then it would be eliminated when I add those up. So that's exactly what I'm going to do. I'm going to multiply everything on this top equation by 2. So then I'm going to get 4x, 2 times 2 is 4 usually, minus 6y equals negative 42. And my second equation can stay the same because that's going to have that opposite situation lined up there for me. Alright, now I'm going to add these up and see what I get here. 4x and 5x is 9x. So far so good. Here's exactly what I wanted to have happen. The y's are eliminated. And negative 42 plus 15, I believe, will be negative 27. Now I have an equation here I can solve fairly readily. X will be negative 3. And then I can just take this negative 3 and put it back in any equation and figure out what y is. I guess I'll go to the bottom one here. So 5 times negative 3 is negative 15 plus 6y equals 15. I'm going to add 15 to each side, so 6y equals 30. And so y will be 5. Therefore, the solution for this system will be the ordered pair negative 3, 5. Most students like this method pretty well, and it works out pretty readily. Now, the next one is going to be a little through this, and we'll definitely show you how to do this tomorrow in class. To solve using matrices, you're going to use your graphing calculator almost exclusively on this one. And so I'll just kind of talk you through it here a little bit, and we'll work on this in class tomorrow, certainly. Perhaps you see that we can actually, a problem like this when both the equations are in standard form actually looks like a matrix, doesn't it? I can make a matrix out of my coefficients like this. I can make another matrix out of my answers, so to speak, like that. And you might remember that matrices have various sizes. We call this one a 2 by 2 matrix, 2 rows and 2 columns. This one, meanwhile, is a 2 by 1 matrix. You also may remember that in order to multiply matrices, certain things have to be true, and we say that the columns of the first have to equal the rows of the second. Looks like that would be true in this case. So what I need to do on my calculator is go to your matrix, and so where that is the matrix key is right here. It's the second of that x to the negative 1 key. So if you press that, you get into the matrix mode. You can enter each of these matrices in your calculator, and then ultimately what you're going to do is you'll give them a name, and we'll just say that our 2 by 2 matrix is matrix A, and our 2 by 1 will be matrix B. Now, we aren't going to just multiply them, because that would not enable us to solve for our variables. What we're going to do is take the inverse of this first one times our second one, and that's going to give us the solution that we want. We'll perhaps go over this one in class tomorrow. It's a little bit hard to show it on the iPad here. You can try it yourself. The answer you should come up with is the ordered pair 3, negative 1. But this is a real slick way of solving systems. We'll see this especially when we have 3 equations and 3 variables, which is kind of tedious to do algebraically. Works out very nicely with matrices. Conclude with showing you this little chart. There are some terms that we have for systems of equations that are not necessarily crucial, but they show up once in a while, so it's good to tell you about them. Here are the 3 cases that could happen when you have 2 lines. Of course, they could intersect, they could be parallel, they could coincide, which means they're the same line. Here's our number of solutions in each of those cases. Here's the classification. We say if there's at least one solution, it's called consistent. So notice that word appears a couple different places. If there's only one solution, it's called independent. So anytime we have two lines that just intersect once, which happens most of the time, that's an independent situation. If the lines are parallel and no solutions, we call that inconsistent. And if they happen to coincide the same line, then it's consistent and dependent. All right, so thanks for listening, everybody. We'll work on this in class tomorrow, and you can see if this worked on your computer or other device. And we'll see you then. Bye now.